Hey guys, I'm back with another video. Today I'm yet again trying something new, but this time with visuals. I got a new tablet, one in which I can see where I'm drawing, which makes me much more comfortable drawing. I thought, what better way to use this bad boy but by using it in a YouTube video or two. Not to mention, helping my art skills get better too. So this week I wanted to talk about habitat fragmentation. The definition that Google provides is that habitat fragmentation describes discontinuities in an organism's preferred environment, causing population fragmentation and ecosystem decay. So to put this in an example, imagine you have a forest. Then you have cities, villages, hubs, and people want to travel between them. So they lay a road through this forest. This divides the forest into two distinct habitats. Now imagine that the cities start to prosper more. So this road needs to hold more traffic. Then there are new places sprouting up in the north and south. They need to be connected and bigger, but the roads also require maintenance, so there needs to be room for construction vehicles. This splits the land further and further from the once big forest to smaller sections of that forest. Looking familiar? So how does habitat fragmentation actually affect a species? Well, we don't fully know the effects of habitat fragmentation yet. Many scientists in the ecology community have done experiments simulating the effects of fragmentation, with them looking at random, grouped, and regular distributions of individuals in a fragmented area. But the problem with this is that there isn't much data on the distribution of populations of a species in the continuous habitat, or in other words, the habitat before it becomes fragmented. This doesn't give us the prior context of species population behaviors, which hinders full understanding of what happens to them after fragmentation. This is also tied to the SLOS problem, which is whether to preserve a single large area of habitat or several small fragments. So we have to both understand how fragmentation affects a species and how big the fragments should be to have the least impact. But when looking at the actual research, the results were surprising to me. Much of the research found that habitat fragmentation actually helps benefit species, though this can depend on the species themselves. As with fragmentation, there is something else that occurs: edge effect, which is essentially when there is a fragment, the perimeter of the habitat increases compared to before the fragmentation. This allows for more species suited to these perimeter habitats to thrive, while possibly having an adverse effect on species that live in the interior of the habitat. But again, this all does depend on the typical behavior of a species. Let me know down in the comments below if you would like a video diving deeper into the edge effect and how this impacts species diversity. One particular study I looked at that was done by Felix May, Benjamin Rosenbaum, Frank M. Schur, and Jonathan M. Chase used data for three population distributions: random, aggregated, and regular or even spaced. They used this to make simulations of the effects on species population distribution due to habitat fragmentation, while also looking at how the different sizes of the fragments affected populations as well. They found that random distribution was unaffected by the fragmentation unless the amount of the habitat was inherently smaller. For aggregated populations where individuals tend to cluster, they found that when the overall habitat was larger and there was more fragmentation, the higher the rate of survival, but have much less variation in populations. With regular distribution, where the individuals were evenly distributed throughout the habitat, the amount of variation was low compared to the survival rates in almost all amounts of habitat, with the lowest amount of habitat having the biggest impact on survivability. However, it was mentioned in the study that these results are still considered almost negligible with these variances. But again, data of populations prior to habitat change is really needed to form a whole picture. Nonetheless, there have been strategies to help try to reduce the impacts of habitat fragmentation, with focus on improving the quality of habitat that has been left intact. Thus, we have created methods like wildlife corridors, which are stretches of untouched land that animals can safely travel between, or land bridges over highways that work the same way as wildlife corridors. Even though all this research has been done, there is still a lot more needing to be done, with us still knowing so little about what habitat fragmentation has done and what it will do to the species we live with. Well, that is it for this video. Thank you for watching. Links for the resources are down below in the description. If you enjoyed this video, click that thumbs up to get the algorithm to notice me. Hit that subscribe button if you haven't already. And leave a comment letting me know what you think of this format. I enjoy trying out a bunch of different stuff and want to know what you guys think. As always, I'll see you in the next one.